નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Hello students, today we will continue our exercise 6.3. This is the topic of standard 10, chapter number 6, triangles. Today we will study the question number 8. What is the question? Here in this question we do not have to give the diagram. Question is, E is a point on the side AD produced of a parallelogram ABCD and BE intersects CD at F, so that triangle ABE is similar to triangle CFB. So here we have given that ABCD is a parallelogram. AD side is extended to point E. When we join E and B, it will intersect the BC at a point F. So this is the diagram that we have to draw from the given information. Now we have to prove that triangle ABE triangle is similar to triangle CFB. So this is the question, this is the diagram, this is what we have to prove here. So let us start. Here we know that ABCD is a parallelogram. So here we can use the property of the parallelograms, and that is the property is opposite angles of a parallelograms will become equal. So here we can write down that angle A is equals to angle C. Angle A will become equal to angle C. Now see, angle A is included in this triangle ABE, and angle C is included in triangle CFB, right? So now we can write down this angle A as angle, we can write down it as a BAE, and this triangle angle C we can write down as angle FCB, right? So this is the condition number, let us give it equation number 1. So see, in these two triangles, one of the angle we get that it is equal, and it is due to ABCD is a parallelogram and their opposite angles will become equal. One of the angle is included in triangle ABE, second one is included in the triangle CFB. Now in the same way, we have to check out for the other angle. See, here two lines are intersecting, so these two angles will become equal according to the vertically opposite angle, but this angle is just included in triangle CFB, but this angle is not then included in triangle AB. So think about the other angles. Which angles we can think here is see, here we can use the alternate interior angle, right? See, we can take that AB and CD are parallel. We can write down that AB is parallel to CD, and if we consider BE as a transversal, BE is transversal, then what will happen? There is Z is formed here, see, right? So this angle and this angle will be equal according to the vertically opposite angle. So this angle we can write down as angle AB, instead of F we can write down ABE, right? Angle ABE, and this angle we can write down as angle BFC, angle BFC. This we can write down according to the alternate interior angle property and give it the equation number 2. Now see, this angle ABE is of triangle ABE. This angle BFC is of the triangle CFB, but we cannot write down it as a BFC. Okay, let us write down it as a ABE. We can write down it as a CFB, angle CFB, right? Give it the equation number 3. Now see, from equation number 1 and 2, if the two two angles of a triangle are equal, then by angle-angle similarity criteria, we can say that both the triangles are equal. So, from equation number 1 and B, we can say that triangle ABE is similar to triangle CFD. By which rule? We can say it by angle-angle criteria or angle-angle rule. So this is how we can prove the two triangles similar using the alternate interior angle criteria and opposite angles of a parallelogram. Okay, the main thing is to draw the diagram. Okay, now let us study the question number 10. Here also the diagram is not given. So, what is the question? CD and GH are respectively the bisectors of angle ACB and angle EGF such that D and H lie on sides AB and FE of triangle ABC and triangle EFG respectively. If triangle ABC is similar to triangle FGE, then we have to show here the three conditions. How we can draw the diagram? We have said that the two triangles ABC and EFG are there. CD is the angle bisector of ABC and GH is the angle bisector of EGH. Okay, so this D point is on side AB and H point is on side FE. One thing we have given is that triangle ABC is similar to triangle FGE. First thing we have to prove here is that CD upon GH is equal to AC upon FG. AC upon FG. This thing first of all we have to prove this thing, right? So see, these are the two sides which are in the same proportion. It will happen only when the two triangles are similar. So which two triangles considering this? See, one of the triangle we can consider as a triangle ACD. So one of the triangle we can consider as a triangle ACD. Okay, which two triangles we required? Triangle ACD. And another triangle that we required is FGH. Triangle FGH. FG and H. These two triangles, if we can prove the both are similar, then we can write down that these two sides are in the proportion. So how we can prove that these two triangles are similar? Let us see. Here we have given that CD is the angle bisector of triangle AC, of the angle ACD. So two angles ACD, angle ACD will become equal to angle BCD, and both are, these two are equal to 1/2 of angle ACB, right? Give it the equation number 1. In the same way, in this triangle also we have given that GH is the angle bisector of EGH. So EGF. So we can write down that angle EGH will become equal to angle FGH. Angle FGH. And both are equal to 1/2 of angle EGF. EGF. Give it the equation number 2. One more thing we have given is that triangle ABC is similar to triangle FGH. So see, in both this triangle, one of the angle C is included in the triangle ABC, and angle FGH, one of the triangle G is there. So from this we can write down that angle C is equals to angle G. Angle C is equals to angle G. Right? From this we can write down this thing. Or in extended form, we can write down that this angle as angle ACB. Angle ACB is equals to angle ACB is equals to angle FGE. Angle angle FGE. Right? Now, if the two angles are equal, then the halves are also equal. So one half of angle ACB will equal to one half of angle FGE. What is we can write down? One half of ACB. One half of ACB we can write down these two angles. But which angle we required? We required angle ACB. So here we can write down angle ACB. And here which angle we required? FGE. Right? Here we required one half of FGE. One half of FGE. That means we can take this angle FGH. Angle FGH. So for both this triangle, one angle is equal, right? ACB, one angle, and FGH, this angle. One angle we have proved here that are equal. Second angle we have to prove that they are equal. So which angle we can prove? See, in ACB, A angle is there, and in FEG, F angle is there. So according to the similarity criteria, we can write down angle A is equals to angle F. Angle A we can write down as angle BAC. Angle BAC. And here we can write down the angle. If we have taken BAC, we can write down EFG. Angle EFG. Right? But here which angle we required? Instead of BAC, we require DAC. So we can write down it as an angle DAC. And here instead of EFG, we can write down that HFG. Angle HFG. Give it the equation number 1. Give it the equation number 3. And give it the equation number 4. Right? How we can write down these two things? According to the equation number 1 and 2, these two angles we can write down in this way. Okay. Now from instead of BAC, how we can write down DAC? Instead of BAC, we can write down DAC because B and D are collinear. Angle A is there. We are not changing the angle. In the same way, instead of FGE, we can write down HFG because F angle remains the same. So from 3 and 4, see, in these two triangles, two angles are equal. So from 3 and 4, we can write down that triangle ACD is similar to triangle FGH. If the two triangles are similar, then the corresponding sides are also in the same proportion. So we can write down the CD side is, if we are taking CD side, we have to take the GH side. So CD upon GH will become equal to, if we are taking AC side of this triangle, we have to take FG side of this triangle. So this is the first criteria, first thing that we have to prove here. Okay? Okay, so second thing that we have to prove here is that triangle DCB. Second thing that we have to prove is triangle DCB is similar to triangle HGE. Triangle HGE. Right? Okay, so see which two angles or which three angles we can prove here. They are similar in this two triangle. One is DCB. DCB and one is HGB, this triangle and this triangle. See, angle B and angle E are, we have already proved that here B and E of this, as the these two triangles are similar, we can write down that angle B we can write down as angle ABC. But now here we can write down it as a DBC, right? Angle DBC are equal to angle DBC. So we can write down as HEG, right? Because basically ABC will become equal to FEG. But here instead of ABC we are writing DBC. So instead of writing FEG we can write down HEG. So in this two triangle, one of the angle here we have write down that it is equal. Now what about the another angle? See, this angle C of triangle ABC is divided into the two equal parts. So which angle we can take from here? DCB. We can take the triangle. We can take the angle DCB, right? But if angle C and G are equal, yes or no? Yes, angle C and G are already equal. So we can write down that angle ACB is equal to angle FGE. From this we can write down this condition. Now angle ACB, see, angle ACB we can write down as ACB is divided into the two parts. So if we take one half of angle ACB, here also we have to take one half of angle FGE. So one half of ACB now we can take as angle BCB, right? Angle BCB, and as a one half of FGB, we can take the angle FGH, right? So this is the, we can take it equation number 5, and this we can say the equation number 6. So in this two triangle BCB and HGB, two angles are similar. So we can, two angles are equal. So we can write down that from equation number 5 and 6, the triangle BCB is similar to triangle HGE, right? By angle rule. So this is the second thing that we have to prove. Now let us try the third thing that we have to prove here is, third one is triangle BCA. Triangle BCA is similar to triangle HGF, right? The same thing here we have to do whatever we are doing here. See, in both this triangle, from this given condition, which angle we can take? See, angle A is that, and angle G is that. Sorry, angle E is that. F. Now A and F both are equal. So as we have written down here that the angle ACB and FGB are equal. In the same way, here also we can write down that instead of here A angle and F angle are equal. Let us write down it as like angle BAC. Angle BAC is equals to angle BAC, then EFG. Angle EFG. Now see, instead of BAC we can write down DAC because B and D are collinear. So angle BAC we can write down. And instead of FGB, EFG we can write down HFG. Angle HFG. Right? Give it the equation number 7. So one of the angle of these two triangles are equal. Now think about the second angle. We can take this angle only because ACB. Whatever we have done here, we have to do the right thing. Same thing here. One half of angle ACB we can write down as equal to one half of angle FGE. Now here one half of ACB we have to take as an angle ACD. Angle ACD, and instead of one half of FGB we can take here FGH. Sorry, EGH, right? Angle EGH. This is the equation number 8. Now see, in both this triangle DCA and HGF, two angles are equal. So from equation number 7 and 8, we can write down that triangle DCA is similar to triangle HGF by angle rule of similarity. Right? So these are the three things that we have to prove here. CD upon GH is equals to AC upon LT, that we have proved here. Second thing we have to prove, these two triangles are similar, that we have proved here. And the third thing that we have to prove is we have proved here. So all this we can do by the angle similarity criteria. Okay? So in this way we can solve this type of questions. This is all about this lecture. Thank you. Thank you for joining us.